Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Carl Carlson.
And this is Chris Jackson. And today, Carl and I are going to be talking about how to allocate reliability goals. Actually, probably should go one step back. What is allocating reliability goals?
Yeah, it's you know how this came on my radar, Chris. It's almost it is humorous.
Mm-hmm.
We have consolidated our residence into a condominium and moved from Michigan, where I had 30 years of boxes and records and electronic files and you name it. And it's been an amazing journey to go through those decades of boxes and records and thumb drives and basically surface all the things that we're trying to downsize and look at and just decide whether we keep. And one of them I stumbled across was one of my first presentations. In my early reliability career, I was actually, for a short time, manager of reliability of the EV program, EV1 at General Motors.
Mm-hmm.
And that lasted a few years, and it didn't come to fruition at that time for a lot of reasons. But I noticed the primary reliability technique they were using was reliability allocation to set their reliability goals. And I was in the middle of developing what I thought was a good approach to design for reliability, which is a very different subject. And I didn't want to limit the reliability effort to allocation. And so I wrote this presentation called The 7 Pitfalls of Reliability Allocation. And it presented to a number of people, and then it got filed away. And then I just discovered it a few weeks ago. And so I thought I'd share some of those with you and just kind of muse about it and really talk about, is reliability allocation a valid methodology? Which I think it is, but it has to be done within certain contexts. Or is it a waste of time? Or when should you do it? And how do you do it? That kind of thing. So I'll just throw out a couple of the pitfalls and kind of bring them up as we talk. But
do you want, for those listeners who don't know what reliability allocation is, Carl,
please,
do you maybe want to run through what it is first?
Oh, sure. Well, what I mean by it is if you start with a high level reliability for a system, let's say you're making a widget system and you want it to be 95% reliable in the field, in use, under all the conditions of the 4 aspects of reliability that we've talked about.
So at a certain point in time, like a warranty reliability.
At a certain point in time, under certain conditions, based on the functions of the widget, that type of thing.
So like my microphone I'm talking into right now, you want it to be 95% reliable at 2 years being used in an office-like environment.
Yeah. Under the function, in other words, it has to have a certain quality of sound.
So it doesn't matter if it still works, but there's an annoying hiss. That's still, from the customer's perspective, a failure.
Yeah, that's one of my pet peeves is people thought reliability was, reliability is only does it work or not. No, it needs to function to certain requirements. So let's say you have a 95% for your microphone, but the microphone has lots of parts. It has the elements. I won't go into what all goes into a microphone, but different elements. And those have different suppliers or can have different suppliers. And you could allocate that 95% to the components of the microphone. And that's what we mean by reliability allocation. So if you have a tank, then the tank overall has a certain reliability. Well, then the turret assembly has a reliability, and then it's different. The tread, the wheel system has a certain reliability, and the etc. And so that becomes useful because your testing is not always at the system level. And so
No, and especially if you purchase, or not even that, it's also if you're purchasing components from third-party suppliers and you're trying to tell them what the reliability of that component needs to be.
Exactly. And so reliability allocation is the methodology to decompose a higher level reliability number to lower levels. And there's good ways to do it and bad ways to do it. And that really is the subject that I wanted to talk about today, is what's a good way to do it and what are the bad ways to do it.
And there's 7 pitfalls. So yeah, I'm keen to hear what they are.
I'll give you one. The pitfall, this is number 7, but I wrote down this is the biggest mistake of all. So I'll start with it. Believing that reliability.
I think I know what it is, but sorry.
Yeah. On the edge of your seat. Believing that reliability does not have to be engineered into the product or process. And the reason I wrote that down is people were thinking if they've allocated the reliability and communicated to suppliers, they've done their job from a reliability point of view. And I'm going, oh, no. That's a tiny part of your job. The biggest part of your job is getting reliability engineered into the product and into this process. And so I called that a pitfall. It was a mindset that reliability allocation was enough.
Do you know who's the worst for that?
Say it again.
You know which organizations are the worst for that pitfall?
Yes.
Militaries.
Yes.
My opinion, I should say, is the militaries. They just have contracts and they go out there, say, you meet this requirement, and you say, well, are you going to let them speak to soldiers? No. Are you going to actually train them to do the stuff? No. Are you going to tell them what you're most concerned about? No, that's their, why we're paying them to do this. Why we help them to do a job that we paid for is the sort of common attitude that I come across in military organizations.
It's their job to do it and da-da-da-da. Yep.
Right. Even though in many circumstances, the companies making the next tank and the next vehicle and the next aircraft, it's not like a production line at Toyota where they are making roughly the same number of cars year in, year out. You'll often have organizations who completely disband workforces once that thing has not had that once, tank A has been designed and that workforce disappears, and a couple of years later another contract comes out and they hire a bunch of brand new people, and the only continuity from tank A to tank B is the army, for example, who drive it and know what the conditions are and know what the likely failure modes are. But no, it's in a contract. We tell them, here's a reliability. We're not going to help them because that's their job. We're paying them to do this, not the other way around. Anyway, so that's, I would agree with that.
Yep, very good. So, and then another one, just kind of randomly here, is one methodology is obviously system reliability modeling, which is its own subject. And just for listeners to know, I mean, Chris does a great job of teaching that subject. And so it's not something that a 20-minute podcast is going to dive into very thoroughly. But one of the methods for allocating is just to make certain assumptions. And you say you have 7 parts in the microphone.
Yeah, we go.
Yeah. And then let's say you just assume that they're all equally contributing and they're all in series. Like if one fails and the whole thing doesn't work, well, then you can do a really simple mathematical calculation, and you're missing that. Those assumptions may not be correct. And so you need to understand the actual modeling of the system, whether there's series or parallel. And you also need to understand whether certain components are more critical than others. And so there's a lot that goes into it, but making wrong assumptions about the methodology of decomposing would be a pitfall. So that was another example.
Well, just to expand on that, I think it's important for people to know that you can't just, like, if you have a reliability target for your microphone of 95% and you have 7 parts. Well, if you just say, well, let's just give every component, it's a target of 95%. And then you get every component, all 7 components have a reliability performance of 95%. And when you do the math and do that system reliability modeling, well, it turns out your microphone will only have a reliability of about 69%. 70%. So why, I think just to bring your point home, Carl, is that when you have a target of 95%, essentially, in a way, a better way of looking at it is you have a 5% probability of failure that you can divvy up to your components. And what you don't want to do is, if you, like, I'm looking at my microphone now, and one of the simplest components is the metal stand that holds it up. Very simple. I would expect that's going to be the last thing to fail on my microphone. Whereas the condenser part of the microphone, where all the wires are, the sensitive wires, I'd expect that's going to fail before my fairly robust metal stand. And so what you want to do is you want to give the condenser part of your microphone the easier target. You want to, in a way, allow it to have a higher chance of failure when compared to your very simple bass stand, because that then can slash development time. Because if you're trying to make your condenser as reliable as your metal stand, well, that could take years to try and get something that robust. But if you allow it to have you have a bigger slice of that pie of failure, then it essentially makes it easier to come up with a satisfactory condenser part of your mic, which is going to slash development times and budgets.
Yeah, very good. And using the microphone again, in even the metal mesh cover, imagine that the metal mesh cover starts to look bad.
Corrodes, yeah.
Okay, yeah, corrodes. It just looks bad in some way. Well, okay, compared to the condenser failing and not working, and which means the microphone doesn't work, versus the cover looks a little grody.
Yeah,
they have different consequences, and some are worse than others, and that's part of the equation. So when you allocate reliability, you want to make sure that the critical failures that can make the system not work at all are given a higher emphasis than something like if the shell gets a little corroded or some such. So we don't want to get into purely a mathematics game. You want to understand your customer and what's important to the customer, and whether the thing looks nice. In some cases, how it looks may be very, very critical to the product success, and in other cases it isn't. And so there's a certain amount of back and forth and balancing that has to occur on requirements. So yeah, that one. And then another one I just did as a kind of randomly bounced around. I have a concern about the use of the word goal. And let me explain. Back in my GM days, reliability was a goal. Now, what they meant was it wasn't a requirement. They meant this is what we're going to aim for, and it wasn't part of the requirements document. You didn't see it in the technical specifications originally, going way back. And the internal management treated it as a goal. Well, we'll aim for a certain reliability, but if we don't make it, no big deal because it's only a goal. And so we changed the words to requirement, and then we put it in the technical specifications so that it actually shows up on the stage gate reviews as part of the decision whether you move forward on the project. And that was a very different commitment. So I have a hunch that when you say goal, that's what you mean. But I think when some people think of the word goal, they think, it's what I'll aim for, but it doesn't have to be done.
And I'll actually go in another way. In other scenarios where people are huge on demonstration testing, where you have to take into consideration what they call a discrimination ratio. So long story short, to pass a demonstration test, which involves statistics, if the requirement is 95, you actually have to have something which has a higher reliability, say 97.5, so fails less often, to have a reasonable chance of passing the test that demonstrates reliability is 95 or higher. And so in some cases, we actually have what we call goals where teams actually, the requirement's 95, but our goal is 97.5 because we know we have to pass a demonstration test. And not to challenge what you're saying, it's just that how many many words can be used in different ways and contexts. And regardless of what words you and I use, Carl, I think everyone who's listening should interpret those words back to their environment or their organization.
Yeah, makes sense. Makes sense. Another one that I had in my presentation, which I think if you put two reliability engineers in a room together within 20 minutes, you'll be talking about MTBF at some point.
Sure.
And so the second pitfall is making inaccurate assumptions. And this is back in the early 90s, I wrote this.
Right.
Such as exponential distribution in order to facilitate the allocation procedure. In other words, mathematically, it's so much easier if we just assume exponential. And so many people were doing that back in the early 90s.
So many people are still doing it.
Some are still doing it. Oh, I hope none of our listeners are doing that. Is anybody out there still doing that? I wonder, but I bet there are.
We have a lot of listeners who have to do it because they're told to as well. So there's that third category.
Chris, do you remember when you and I were doing the RAMS presentation?
Mm-hmm.
And it was probably a couple of years ago where we were doing it together on reliability management. And at the very end, a few people asked questions about, well, we're told to do something that we know is not right.
Yes, I do remember that one.
Do it. And it was a really good question. What do we do was the question. So if you're being pushed to make inaccurate assumptions like exponential distribution, my personal belief, and this is so easy to say, but I stuck to this in the early 1990s since then, but I believe you have to stay with your integrity on this.
I could do it.
If you compromise your integrity because you're told to do it, then you basically lost your sense of self, your personal contribution, and you become more like a robot, which used to be a bad thing. Now it's not so bad. So I think you have to maintain integrity on that, and you have to find ways realistically of working with the team, but getting your message across. So not an easy task, but that was a pitfall, is making inaccurate assumptions facilitate allocation.
Concur.
Yeah,
yes, I remember,
I knew you
remember
would.
that. Yeah, and one of the things I flippantly said to that gentleman was just get your LinkedIn profile ready, because sometimes it's just hard to get cultural or organizational change. And yeah, anyway, that's a whole new podcast.
You know, one of the ones I didn't include on this presentation that I put together in the early 90s, which I added later, I'll just mention here, is interfaces.
Good point.
I'm going to say not the beginning of my career, but mid-career, I learned that more than half the problems occur at interfaces. And so if you're doing system reliability modeling or allocating, and you omit interfaces as a contributor to reliability problems, then your numbers are not going to add up, so to speak, because so many problems occur at interfaces. So when you model reliability and allocate, you have to keep in mind the interfaces between subcomponent A and B, and then you have the interface AB, because that's where the problems might be. So you have to kind of take that into consideration. What are your thoughts about how to consider interfaces when you're doing allocation?
Well, I think it's very hard. And when I do, like, very coincidentally, Carl, I was actually sprucing up my reliability allocation course just before this podcast. I say people associate equations with reliability allocation. Okay, so we get the goal, the requirement at the system level, and we put numbers into equations that are taken into consideration complexity and criticality and all those things we talked about. And we spit out numbers for the components and subsystems that allow suppliers and design teams to independently work towards those targets, those requirements, those goals. But I say the first thing you need to do, whoever is a design team leader or whoever's in charge, you need to keep some margin. And so, for example, if the requirement is 95%, then the design team leader, first thing needs to do is keep maybe a third of that in their back pocket. So what do I mean by a third? A third of their 5% failure probability. And so that means that the target now goes from 95% up to 96.3%. Is that right? A third of 5%? No, it's 96.6%.
Okay, there we go.
There we go. And so all of a sudden, everyone's now working towards a higher, let's call it a target now to separate it from a requirement. Noting that the design team lead has that 1 2/3 percentage of points of failure in their back pocket. Now, the reason I teach people to do that is because you can have a pretty good guess about what your reliability challenges will be, and you'll give nominally those components which are going to have more challenges. You want to give them the bigger slice of the failure pie. It's no point trying to make them as reliable as simple components. That's just a dumb way to blow out budget and schedule. But by keeping that margin in your back pocket, what it means is that everyone's aspirational based on from your first best guess. And so when team A or team B or supplier C says, hey, I don't know if we can meet this requirement or this target that you gave us, straight away, the very first thing you can do is give them some of your margin. So, okay, all right, so you're struggling to meet your target or allocated, it's 99.8% because these targets are very high. The more components you have, the more ways things can fail. That means that the component allocated targets are going to be very, very high. You're dealing 99+% for every single component. And so changing the requirement or the target from 99.8% down to 99.5% could be huge for one component. And you can do that easily when you keep that margin in your back pocket. And the reason why I'm saying that, Carl, is because that in some way mitigates some of the interface challenges you will come up with. The other thing that interfaces, as you know, the vast majority of interface issues come from just stupid decision making. So you look at the Mars Polar Lander and the Mars Climate Orbiter. That was a 2 spaceship program from NASA where both craft were destroyed during their missions because essentially of interface issues. The components worked fine, but they just blew up and impacted the surface at a great rate of knots because of, we won't go into details, but just things weren't communicating the way they were supposed to.
Same with Apollo 13 had a interface issue regarding the voltage requirements of certain components, which are a source of the problem. So, but that's very interesting. So you're thinking use a design margin approach, and that's probably a good idea. Another possibility is you could actually take an interface if you're concerned about it. Like you have component A, component B, you could have interface AB and make a box out of it and say interface AB has got a certain allocated liability. So some different possibilities. I would love to hear from listeners on what I should do. What should Carl do to update his presentation? What are your experiences regarding reliability allocation? Do you have
Aren't you retired, Carl? What are you updating your presentations for? You are one of the worst retired people I've ever come across.
I failed retirement.
You suck at retiring.
Yes. No, this is more of a hobby at this point. So this is pure hobby. So what are your, as a listener, do you even do reliability allocation? Where does it fit into your program? And for reliability, how important is it? And if so, how do you do it? And what questions do you have for Chris and I? So how should people get in touch?
Well, Carl, most of our listeners know the Ascendo Reliability website where our contact details are. Reach out to us on LinkedIn or whatever mechanism works. We always respond to comments and queries and questions. Also, if you want to, you can go to www.ascendoreliability.com/go/SOR, and that will take you to a page where you can type in a message or even record your voice asking us a question or making a comment about what we have done or should do or anything in between. And we take all these comments and questions very seriously. In fact, I think good 2/3 of our podcasts stem from listener questions or comments or requests. So we really encourage people to reach out to us, and also reaffirms that people are listening to us bang on about reliability.
And it makes us think, and it's part of the joy of life is to hear from people and basically to grow by interacting and that type of thing. So we really do want to hear from you.
And,
all right.
Even retired people get a kick out of reliability, it appears.
That's right. Well, nice talking with you, Chris.
Always a pleasure, Carl.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.